So the idea behind this presentation is that I was actually at the Construction Progress Coalition Summit, and we were talking about things, and stuff started to really click on a level there with them that tied back into BIM and VDC. And when things tie back in for me, it's because we're getting more productive. So the whole purpose behind BIM, VDC, Lean, all of that is to get the people that actually build these buildings, structures, roads, whatever it is we're building, get them more productive, because that's what changes our bottom line. That's what changes everything. And so then I start to try to pull that together into concepts and principles that I can come and share with others at the conferences, because I'm not ambitious or anything, I just want to change the industry. That's it. I just want to change everything, right? And so that's kind of where we are and coming into this, and I'm going to start down this road. If I'm diverging, pull me back in, right? If I'm not answering your question, raise your hand, let's hear it, let's go through, and let's have a little bit of fun for the next hour and walk away with something, as Steve requested, something he can take home and use. Okay, so ignorance. Now somebody sitting in back, I don't know if you can see all of this or not, but being not aware of important information or facts, we've all seen stuff like that happen on a project, right? You're done and just, how in the world? For those of you in the back, I don't know if you can see it, somehow we ended up with a power pole in the middle of our front driveway. That's not the desired result. And then of course, deliberately disregarding important information. I'm sure this was a mistake at one point in time, but somewhere along the way, someone had to say, oh, forget about it, just put it in, right? They're just pissed at everybody on the job, and that's it. That's what the drawings say, I'm just going to do it. You know, so relationships have broken down to get to this point. Okay, so those are things that we really ought to be able to control. Now, chaos is something that creeps way into every one of our projects all the time. So what are elements of chaos? Well, why in the world would you go and dump all the bricks out on the ground? So what is the chaos behind that? There had to be some reason behind all of that. You know, and then some degree, and that's disorder, and then confusion, right? How was this really supposed to go in? I mean, you can tell by the bars, this is a prison, and so how this is put in is fairly significant, because if you do it wrong, somebody might die someday. But so there, just what's happening that all this kind of gets left out and put together at a later date. In here, the simple part of the confusion was this window is backwards. The glass is supposed to be on the other side of the bars. And that's a big deal if that's a safe room. So if there's a riot in the prison, that's where the counselor and the guard in there, and that's where they hole up for 24 hours to get things under control. So yeah, it's a big deal. So how do we start to get past the chaos and the ignorance? And really, I want to focus on the chaos and ignorance, because I want us to get that goal of having order and understanding, of being able to do things. So if you look closely, at first glance, you think that might not be what was desired. But in reality, that had to be exactly what was asked for. In this case, you had to have an owner that specifically wanted that window. And how do they communicate that? How do you get that one-off thing in the building when you've got 40 or 50 workers that are all going to look at that? They're going to look at the plans and say that's wrong. They're going to look at the hole. They're going to say that's wrong. But that's really what was wanted. That takes order to be able to do those special things. And then productivity and efficiency. How much concrete are you going to pour that day? Are you really going to get away with a 6,000 yard pour? Are you ordered enough, and are you organized enough to put that together? And so in order to get to that, that's what we're going to talk about. So here's our learning objectives. Okay? BIM establishes a collaborative environment. Okay? We use BIM to increase our accountability, make sure everybody is getting us the right information. Now, how do we really do that? I want to address that some of the little tricks and techniques out there that make the difference. And then we want to increase general contractor and trade profitability. And now that is somewhat tailored to this crowd here today, but it is also the general goal of all of BIM, VDC, Lean. And that's what we have to be doing to make a difference. And then, how do we use BIM to avoid common legal problems of the past? That's also usually avoiding chaos and ignorance. So those are the main goals I'm after. Once again, let's talk about them. Let's talk about how we go out there and build great buildings. whatever that role is. And we also, the company I work for does heavy highway. We also do industrial. BIM is most applicable in a commercial environment, and so you're going to see most of my examples from there. But I can tell you it carries over into any element in which we are building, constructing, creating. So, traditionally, most projects have ended up here in this tug of war. So, from your experience on a construction project, who do we end up playing tug of war with? Throw me out some names or groups. The architect, okay, that's usually one of the first ones. Others? The trades, subs? Any trades? Come on, where's the owner, and the trades are supposed to say the general contractor, right? Right? We get in these arguments with each other. And sometimes we start to lose the point that our goal is to build the project. And we really should be all in the same time working on the project. And when there's those difficult situations, how do we help each other through them? I've heard that way too many times on projects where somebody is falling down and failing, and they're probably walking around and say, well, that's their problem. They're screwing that up. Well, I learned that very heavily on a project where the mason just couldn't get it together, and the mason couldn't get it together. And finally, we got him through it, and we helped him, and we had the mason going, and I started telling the plumber, the mason's coming. He's got it together. He's coming. He didn't believe me because the mason had failed so many times. The mason finally showed up with 7 crews and started cruising through. And then guess what? We're standing around waiting on a plumber. And so those are the things that we want to avoid because we're collaborative to begin with and working through that. Some of you might be very new to BIM. Some of you, I already tell from comments earlier, are somewhat experienced with it. In general, in the past, our first opportunity of putting the building together was when we actually built it. Because all of these drawings were individual and distinct and separate from each other. The principle behind BIM, and this is the primary concept that you're after, is to get as much of that together into a composite model at one time. So that includes architects, engineers, trade contractors. The more pieces you pull together, the more you're going to do to end up with a better construction operation when you're done. And so keep that in mind as we're going through this. Those slides are straight out of the AGC BIM classes. That's where those come from. And that's the guiding principle that we're after behind all of this. And so you can already see the idea of collaboration. When we take the distinct information and we kick it out different directions, we're already creating chaos and ignorance. We're separating this information and everybody's not together. And so the idea is let's start pulling it together. I put this in pretty much all of my slides to walk through the idea that BIM is a process, because there's always individuals that are new to it or haven't played with it yet that are under the impression that BIM is a product, that you get a model. Oh, well, we don't do BIM because the architect didn't hand us a model. Well, wait, that's just one little piece of this pie. Okay, that's one little part. Or we don't do BIM because this person didn't have it or this person did. We can make up and fill in those holes if we need to. But BIM is really a process that hopefully starts with some degree of schematic. And then you're hoping that your design team is actually authoring their design using the model. But there's a little step in there and there's some diagrams I have to walk through that. And then it goes on to your shop drawings and your fabrication drawings and pulling those together. That's where most of the magic happens. Okay? And then what I really want to hit on today is how do we get to field installation and getting it right there? Because when we get it right there, that's what changes the bottom line. Now we can make improvements here, and BIM pays for itself up here in this 3D coordination and all of that. But the real dollars are coming down here, and that's what we're really after. Okay? So, a simple question to begin with that I usually get is what should be modeled? And the general idea that I say is, if you care where it goes, somebody should be modeling it. Right? That's the idea. So if you care where your anchor bolts go and you don't want to be out there doing this, somebody should have been modeling those anchor bolts. Because then you could have verified they were in the right location to begin with. Now I can tell you, this situation wasn't the concrete guy's fault. He put them in there as he was told where they went. Okay? The steel had to move. And then they weren't in the right place anymore and we're still chipping out concrete. You can tell concrete, I'm sorry, you're not in the right spot all you want, it just doesn't move by itself. So on this, there's different things here. You think about this, anybody's in construction, you know, what elements do you care where they are now and in the future? Right? So in some places, do we really care where the outlets are exactly? Sometimes we don't. So they can move 18 inches, 2 feet, nobody really cares. But sometimes they've got to be in the right spot. We ought to be modeling that location. Somebody ought to. So that's a kind of a basic rule. We're talking about early on projects. If you have a vision that might not be easy to explain or might be hard to truly understand what the product is, go ahead and model it. Now I found the vast majority of owners that I deal with, most of them don't have experience reading plans, looking at plans, and getting a vision out of those plans. And so that means that most of the projects need to be modeled, because that way they can actually see it. And so by modeling early on and creating that vision, we can easily reduce our owner change orders by 50-60%. Pretty easy up front, because they find this stuff early. And I'm going to talk about boundary of realization and things like that as we go. Okay. Here's a video that I'm going to play. If we're talking about working together and collaboration on a project, if you're going to be stepping into BIM and you want to change the productivity in your job sites, you need to be doing 4D scheduling. If you're a trade contractor in here, you ought to be asking for it. You ought to be saying, do you have a 4D schedule? Do you have something to show me where this and how this goes together? Because in the time it would have taken for me to even pass out half of the schedules for this project to you, to even pass you the pieces of paper, you already have a much better understanding of this project than most of the people would have ever had on it with paper passed out. You're already seeing the flow. You're already seeing how it's coming together. Now you can dig into this that much faster and easier and actually start to truly understand a schedule. Now that is a big part of fighting chaos ignorance on a project, because most people on a project have no idea how their work relates to anybody else on a regular basis. There might be a superintendent somewhere, a superintendent for that mechanical trade that gets it a little bit, but this is something that you can show every orientation meeting and get everybody out there understanding, at least in a general sense, what the flow and scope of the building is.
So it's a really interesting study on how...
Okay. This particular one is taking that same 4D schedule and taking snapshots in time and dropping them into VR, to an Oculus Rift, to something like that, where someone can walk through and see what the project looks at that point in time. Now we do this sometimes, specific clients, but we're looking to expand this even more. Some clients just need their building done. This particular client, we were coordinating on a major operating facility on a site with lots of stuff going on. There are times when this little road looks like an interstate. And so we get to lay down here and build over here. And so a snapshot in time, and so what I did is I took a particular day that is their known busiest day of the year and showed them, this is what we anticipate your site looking like on the busiest day of the year. And what was the first thing they said? They came back, they said, hey, that bridge isn't tall enough. The stuff we have to drive under, it won't fit. And I said, perfect. That's the exact sort of thing we want to know a year and a half before the project starts. Not 2 days after we've erected this and something goes bump. Because no one would have ever seen it on a 2-day logistics plan. And no one would have ever seen it here unless we dropped into that virtual reality, and I was actually on virtual reality, standing on the road, walking underneath there, and hey, that doesn't look right. And we got it taken care of. So that's collaboration. When we get into trade contractors, so many people think that BIM is just the architects and engineers. But when you start getting the trade contractors, steel involved, this is coordination between structural steel and bar joists. Two different companies providing two different things. There was a bust in the height, right? So internal trusses, small frame members were not tall enough and would have put it all here, and it was really supposed to be here. But we kept, because of modeling, this had gone through a shop drawing process as well, but because of modeling, we catch that before anything's fabricated. That saves a bunch of time and effort, because it's just better to catch it when it's virtual. But that involves pulling it all together. So this idea of the collaboration, it's got to be all of these groups coming together to really make it VDC and to make it work. And that's part of the difference between BIM. BIM is often viewed as that product. Oh, we have a model. We're great. And I often use the analogy, I didn't even put it in the slides this time, I usually do it. Having a model is like having a treadmill, right? You have a treadmill, does that mean you're in shape? Yeah, I know lots of people have a treadmill and they don't ever use it. I know lots of projects that had a model and they don't ever use it and it doesn't do them any good. And so the idea is to try to pull all of these groups together and center them around the idea of virtual design and construction. Now, so that's the idea of taking this accountability and pulling it together. So let's walk into that a little bit. If we're going to fight ignorance and chaos, one of the big results that comes out of that is accountability. Who is providing the information? What information are they providing it? When are they providing it? Walking through all of that sequence starts to become very significant and very important. So here's an example of how that accountability works in a BIM environment. So we have a model from our structural engineer, and that is giving me footings, grade beams, piers. You can see all of that going on here for the building. Okay, so I have their vision of what that looks like. On top of that, I am dropping a structural fabricator's model. Yes, I had the structural engineer steel, but to be accountable, I want to see how the structural fabricator interpreted that. And so then I drop it on top of that, and now I'm talking about anchor bolt locations for a concrete guy. And now I'm making sure that's coming together. Next step, put a slab in. Usually not too difficult, not a lot of thicknesses on here, but I have seen models save people's hide on the classic issue of quarry tile in a kitchen. Because the architect always shows quarry tile in the kitchen, and how often does your structural engineer actually go in the slab and show the 2-inch recess? And then it gets poured without the 2-inch recess, and the jackhammers come out, and everybody's mad at each other because there wasn't the communication. So, next item, there we go. This is a different fabricator. The circular staircase comes from a different fabricator, in this instance, than the structural steel did. So we want to make sure a miscellaneous metals guy. It doesn't seem very miscellaneous, but it was miscellaneous metals. Okay. Ductwork, actually the fabrication, not the engineer's model. In fact, the engineers on this project, structural, architectural models were provided from the design team. No MEP was provided. So we just went straight to the trade contractors to get all of their models. Okay. There's your fire sprinkler added in, electrical, and then your curtain wall, which on this particular instance was a very significant factor. Modeling the curtain wall made a big difference. It was interesting on this particular project, the structural engineer, someone was saving some money. And so what they did to save some money is they were attaching the curtain wall to the steel, but when they attach the curtain wall to the steel, you have, after 4 or 5 stories, you have this expansion that takes place. So they put in a horizontal expansion joint all the way around the building. Now, I don't know how many of you, has anybody in here seen that before and built that? Okay, I had never seen it before. I had never built it before. It threw some flags when the modeling happened. This had been in the plans, and nobody really, it's just expansion joint. Turns out you can't do that with curtain wall. There's no known way to do that. So we had to come back, pull that out, redesign, and put in this extra steel here that what it accounted for was the horizontal was attached, and that's what the expansion joint was attached to the beams that went around the edge of the building. And of course, beams, center of spans, you have to allow for deflection. Well, curtain wall, even if you put the joint in there, you can't deflect glass. It goes boom. And so that was a big deal. Additional lighting, electrical lighting actually, and showing the light radiuses. And then get into finishes. This particular project, we had the laser scan. Not as an as-built condition. I do not promote that. If you're talking about the future of BIM, right? I want to get it right when it first goes in. If I'm laser scanning to see if it's right, well, I've already killed my productivity. I've already put it in wrong, and now I'm finding out it's wrong, and now I'm fixing it. That's no different than we used to do. What I want to be doing is using the models, and I have some slides addressing how I think that's a better way to do that. This particular one was scanning these studs to put the fancy fiberglass coating on them all that made the stair tower really neat. You'll see that in just a second. But they had a little trick. So a trade contractor here, they were trying to play off the chaos on a project. And so what they would do is they would say, we have to have our attachment points for our fiberglass panels accurate within 1/8 of an inch, knowing that the tolerances for all of this is 1/4 of an inch. And so they knew that the tolerances would never be met, and they'd never know what it was, and they could do, and then they could always just come back in and they would prefabricate a bunch of panels. So we laser scanned it. And we gave them the models, and we told them, and we laser scanned to a density that we provided all your tolerances within 1/16 of an inch. Here you go. Here's every measurement you need within 1/16 of an inch. And that's how we found out they were playing a game. It's because they'd already fabricated a bunch of the panels, and then they tried to come back and say, no, we gave you your tolerances, we gave it to you. And they'd just been doing that. So they weren't very happy with us, but they'd been kind of gaming the system. But their regular mode of operation was about 50% waste on fiberglass panels. They would just produce them and then reproduce them. That's the exact waste that I want to reduce, get rid of, and make our projects cost less. So when we're said and done, that's the product we're producing. Okay, and you can see that stair tower is really pretty neat. It's a pretty fancy deal. So now, that's part of the accountability, is how do we get all of those individual partners. I went through that. I talked about a couple different trades and making sure we have their information, their interpretation, and it's right to go in. So the idea, and this is workflow is very important, and people skip steps all the time. Even my own folks within our company, I've got to walk them back through. Okay, if we're doing this right, the architect, we want that architect doing a model-based design. Not creating a model for drawings, right? Because if they tell you, oh yeah, we have a model, here are your drawings. It's like, well, I want the model. Well, we don't know. That means they haven't been reviewing the model. That means they don't even know what's in the model. And that happens on a regular basis. You've got to be talking to them, and we've got to be moving our architects as a whole. That's why I come do these presentations. If every one of you go back and talk to your architects, that's 120 conversations less I have to have next year, right? And so go talk to them. We want model-based design, where the model is authoritative. Now, oh, it's not a contract document. It can be. They just have to get over that. And it can easily be. All that can be taken care of. But the architect doing a model-based design. Then we want civil to be doing a model-based design. Now, how often the civil guys can come to you and say, oh, we don't do BIM. Wait a second. Like 80% of the civil market uses civil 3D. 3D. It's a 3D model. It's already there. Don't let civil people tell you, oh, we don't do BIM. Yes, they don't use Revit. That's okay. They don't have to use Revit. You just get their civil 3D in a 3D format and you're set. Okay? So ask them for model-based design as well. And I have had multiple projects in the last year where when we went to federate and pull those together and make them all match, nobody knew exactly, in order to lay out, where the building sat on the site. I don't know if any of you have had that problem before. You're like, oh, it's around here. Well, I can't go around here. I have to match an existing parking garage. I've got to be within 1/4 of an inch. Otherwise, it's not going to work. Okay? And so we've got to use those two, because the architect kind of figures out all that where it's supposed to sit, but it's got to tie back to a real live point. And so that set modeled origin is your next ticket to success. And picking a real point. Don't let them go arbitrary on you. Tell them to pick, I want a PK pin. I want that point where that surveyor is going to set up and he's going to hit that point is what I want to have that origin be. And I want the architect and the civil to have had that conversation. Okay? Then restructure is going to pull in and they're going to start coming in together. Our MEPSs, okay? And then whatever else we need. Kitchen, pneumatics, oxygen lines, whatever it is you're putting in the facility. Rotary hearth furnace, if you're doing a steel mill, whatever it is, we want that in there. Equipment, x-ray equipment if you're doing a hospital, we want all of that in there. Those are your design requirements. This is an important separation in the trick to being productive and fighting the chaos. They are design requirements. I actually was challenged by an architect about a year ago to completely eliminate design intent from my vocabulary, because there is no such thing as intent. There are requirements that we have to meet legally, code-wise, everything else. There's no intent behind those. That's what we have to be done. So how do we then turn to match that? We have shop drawings. So now all of our means and methods are coming back in shop drawings. Now there's an important process that takes place here because this is a significant savings within the commercial world. Because now we have a chance where we're told what our requirements are, and then the means and methods allows those individual trades to go out to a market and select things that can bring the cost down and be competitive in those. So whether we're using, GE or Sullivan or Square D or whatever it is we're going out there and buying, different times, different markets, we can make it more competitive. That also saves our owner money. That also makes us more productive and efficient. So once we're into that, those shop drawings, that is the key. If it's a shop drawing or coordination requirement, put it in there. So recently we're doing a Trustmark Bank, nice little bank there in town, a good little project. Everybody been telling, hey, the electrical trade, okay, you've got to get your models in. You got to get your models in. The guys are like, no, we don't model. Da, 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 da. They came to me. You got to convince them to model. I said, okay, let's open the specs. We open up the specs. There is no requirement in the specifications for any shop drawings, coordination drawings, or anything. Say, he's off the hook. There's no reason for him to model it. This building, what it is in, the electrical engineer has told us that his design is fit and has enough of the mechanics in it to get it completed. Don't go wasting money, wasting productivity, forcing him to remodel stuff that's not necessary. So that is the ticket there on which models we get. And so from architect, we'll derive things like curtain wall, ceilings, doors, flooring, right? Some projects, no one's going to model the flooring. You get into a project like this with the patterns on the floor and the walkways, or even more a casino, where the pattern on the carpet is supposed to kind of guide you to certain parts of that casino where you're supposed to spend your time, then it gets very significant and important. And so, but how do we know? We look at the specs. The architect and engineer will have told us. Okay, those get federated in. From structure, we're going to pull in steel, concrete, joists, masonry. Not very many projects require masonry shop drawings, but when they do, it's important. Okay, mechanical, electrical, plumbing, sprinkler. Okay. Landscaping, parking, kitchen, security, what other things there are. What other models are required, what they're asked for, you want those shop drawings to be model-based. Now, an important part of what I mean by model-based. Well, let me get to this part first. It's circular, right? You're going to run these through. You're going to get them in pieces. You're not going to wait and do the entire project. Pick the area that's first on the schedule, run it through, get it coordinated, move to the next one, Some systems, like fire sprinkler, always has to bite off a little bit bigger chunk because they're hydronic calculations and sizing pipe and everything. But they're used to that. They'll be okay. All right, so when we start going into this, you can have a simple disclaimer from the architect on their model. And I implied this a little minute ago and led to it. No warranty, express implied, fitness for any purpose, right? Or that the digital model files will be usable or accurate. Why? Okay, so what are they doing? They're actually doing, okay, so let's be collaborative and let's not have the tug of war and sit here and poke fun at them like we always want to, right? They're doing what all the software vendors have been telling them to do for 15 or 20 years. Use the model, produce your drawings, because your drawings are your deliverable. That's what you're contractually obligated to provide. That mentality is wrong. We need to start changing that. They're not contractually obligated to produce drawings, because if that was only the obligation, they would just provide us with a title block and a little circle that says build here. No, there has to be a level of quality and coordination information in those drawings. And so the model is a more effective way to produce that. We just need to get them doing that. So these disclaimers are a great example. If you get the disclaimer, you know you're not quite where we want to be yet. And I would say only about 10 to 15% of firms in the U.S. are at this state. So if we start talking about the future of BIM and VDC, I want to see reliable models coming from our design teams, where they're actually using the model to design. So if you go to Autodesk University, they're going to talk about generative design, where the computer is basically designing it. Well, then you know it's reliable, and as far as the programmer goes, but we'll see. Okay, so this workflow right here, something to watch out for when you go into BIM. Okay, if the design team is creating drawings and then sending those drawings off and paying somebody else or even another department within their group to create the model based on those drawings, the whole thing's going to fall apart. Because I've seen that happen many times, and there's one large group that builds a lot of stuff in the U.S., a lot of stuff, a government organization. They had a lot of this going on, and only 1/5 of their projects ended up being BIM when they were done, even though it was a mandate out there. Because they'll make all of these changes, we'll do all that coordination, that process I talked to you about, but none of those changes, no one ever looks at the model, then goes back and fixes the drawings. Okay? And so it falls apart, and that's what the red arrows are. The disclaimer is a good indication that that's what you're looking at. Okay? So, that's Wiley E. Coyote stage planning, and we know how well he does at everything. Okay. So now, we have architects and engineers that are getting a little bit better. Okay? They're making the next step. They're actually creating the model, and you can see they're not spending double the money. So they're actually making themselves more productive. They're creating the model, and that the drawings in the model are almost the same thing, but they're still issuing a disclaimer, and that comes back because they're not reviewing the model. They're building the model, they're creating sheets, they're handing the sheets to the principal of the firm or that senior designer, the senior architect, and they're reviewing the sheets. Yes, this is a quality product, quality set of sheets, and they send it out the door, and they will give you the same disclaimer. So then what happens is we get here and it fails, because then we start doing coordination and we come back to them and we say, hey, I noticed in your model that all your toilet paper dispensers are like halfway through the floor. They're like down at that elevation. They're like, well, yeah, but that doesn't make a difference. It's just in the model. It's like, well, but we're intending to build off of the model. No, you can't use a model for anything. Okay, well then we were going to coordinate off of this. Well, no, that we know that all the diffusers are at the wrong elevation. It's like, well, can you fix it? Well, no. Okay, so that's another sign. The disclaimer is what gets you there. So watch out for it. That's where this one fails. So you get to thinking, they start saying, hey, we're doing both. The models come from the drawings are the model. It's all the same thing, but they still get you a little bit there. What we really want, and that's minion stage planning. So they're pretty good planners. They're just not quite there yet. Little mistakes that get you. Okay? So now, this is the workflow that we're after. When you're talking to architects and engineers and you're really wanting accountability, you're wanting design, they have design models. Okay? And they coordinate with those models before the contractor's even on board. They're actually exchanging models with their sub-consultants, architect, structural engineer, kitchen designer. They're exchanging models back and forth in the coordination process. If we bounce back to the other slide, they'll say, oh yeah, we send our drawings back and forth. No, that's not going to do it for you. You need the models being exchanged. That tells you that they're really coordinating it. Okay? And then they're okay with you building from their models. So lots of things I say is, hey, yeah, we plan on laying out from the models. And they're like, well, what do you mean you're going to lay out from the models? Yeah, we're going to lay out all the walls. It's like, well, you can't do that. I'm like, well, I mean, we would have laid out from the drawings. It's like, no, we're not responsible for layout. So you're telling me you're not responsible for the layout, and I'm not allowed to lay out from your drawings either, so I can just go put the walls wherever I want. Well, no. You have to put them where we want. This conversation usually takes 3 to 4 weeks over a series of emails, but I have it all the time. It goes the same way, right? I am obligated, according to code, statute, contract, everything else, to follow the design requirements and criteria. That means I have to put walls where they go. Where they say they're not responsible for layout is they're worried about us going in. Are we picking the center of the wall? Are we picking the edge of the wall? How are we interpreting all of that? When the model is right, then things that are known to be good, LOD 300, if we want to get into LOD, like wall locations, door locations, stairs, treads, all that sort of stuff, we know we can lay out from it, and we're good. And the architect and engineer will print drawings if needed. They're a report. Just maybe there's an update. We do want the drawings, and we'll talk about that in a little bit. But and so that's one of the things to look for. Yeah, we just print the drawings. You know, we got to send them to a authority having jurisdiction or something like that. Here, we'll do a printed set for that, but we're really building off the model. Then you've got an architect and engineer who gets it. Okay, so now this is Batman stage planning. There is nothing we can't overcome. I mean, we can even take out Superman if we're planning like this. So, okay, so now let's drop to our shop models. Same principle applies, okay? And it's more widespread amongst our trade contractors. So if you're out there talking to your trade contractors, if they are producing shop drawings and they're spending money on shop drawings and then sending their shop drawings off to be modeled, your process is going to fail. Okay, because what they're doing is now we coordinate with the model just like the other one, and then is anybody ever going to track all of the changes you make in the model, send it back to the shop drawings and have them corrected? They do not. And so you get fabrication off of uncoordinated shop drawings and the whole thing fails. And then everybody's all mad because we did all this coordination and the stuff still doesn't fit. I mean, we had the plan. We could have gotten 5 gallons of stuff into the 1 gallon bucket. We did it. We did it. But now it's not working. And so that's that stage. So once again, we're back to this, right? And we're just going to beat it all in and we're going to make it all fit. And it doesn't, stuff comes out, our trades aren't profitable. We're not changing our bottom line of productivity because we're doing the process wrong. So the other thing that will let you know if something's not right is if they tell you that it takes longer for them to do BIM. Because what they're doing is they're doing their shop drawings and then they have this lag to get the model done. That's another sign. If they tell, oh, it takes too long, they're doing it wrong. Oh, it costs too much, they're doing it wrong. Okay? This is what we're after on our shop drawings, our shop models. Okay? One time, they create the model. They're coordinating, they're using the other models to create that shop model one time. They coordinate as they go. Yes, they produce shop drawings as needed. So shop drawings, some of you might have used models or not. If you haven't spun models around, it is very hard to pull dimensions from the model. Okay? Because you're there looking at it and am I really hitting straight to each other and am I really the closest point? Some of them have better tools that'll tell you closest point, but it's really hard. Whereas a set of shop drawings or actual construction drawings, those lines are very clear, they're called out, it's easy to go build from those. But we need them all to have this coordination process of taking place so we know that everything fits and everything works. So we pull all that together. Now we go directly to fabrication. Things just got real, okay? And so we're going to pull this in a little bit more about boundary of realization and talk about what we mean by things got real, because now if stuff doesn't match up, you've got something really to fix here. And so when the face-off happens, at least we have a high level of accountability. Okay, so when we start talking about coordinating between those and matching, right? If we come here and I walk through this model, the red is the structural fabrication model. Blue is the structural design model. If you'll notice here, 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 you start going back and forth, we're missing an entire balcony. Okay, those are the sort of things that sometimes don't get communicated. Now this was just purely timing, right? Our structural fabricator would have found out about that balcony 2 weeks later. But we were reviewing the model and we were checking out the quantities of glass, and all of a sudden 188 linear feet of glass handrail shows up, which that's a big deal to a glass guy. He's, whoa, my number just doubled, right? And so we're trying to figure that out. We're in the model. We realized that, yes, the owner had added a balcony, but that revision of all that wasn't coming out on paper for 2 weeks. But we had the model now. The big deal was we were going through this design review with our glass guy on a Wednesday, and when were they sending in the order to fabricate steel? Friday. So if we'd have missed that date, you know, another 6 weeks, another rolling, all that sort of stuff that delays the project. So a lot of it's about timing. BIM for accountability, another one here. How are we making sure everybody fits and everybody works? The design was fine on making sure everything fits. Basically what this is a research lab, and they had, I think it was 64 ovens at any given time in here, testing ovens. And so if you've ever done a kitchen, that kitchen hood, here is about 32 kitchens all backed up against each other with all the associated ductwork. And so on this particular one, there was a big fight early on, model the hangers, model the hangers. No, we always just put the hangers in, we always just put the hangers in. When it came down to it, HVAC was fine. Electrical, by the time they hung lights in between all of these hoods, there was no clear path back up. The only way to hang the lights was to use the same hangers for mechanical and electrical. Those are two different contractors, right? So now they have to cooperate and work together. And yes, they had to upsize the hangers from 1/2-inch rod to 5/8 inch rod. Had they not done that ahead of time, we'd have had a disaster on our hands. So that's accountability, making sure everybody's information is in there and we have everything. So that idea of pulling this all together is what makes the difference for making us more productive and efficient on our job sites, because we've built it one time first. Think of this when you're buying software, okay? And I've got this well disseminated through my company now. I don't get people calling me saying, hey, I saw something cool. At least they say now, hey, I saw something productive. I saw something that'll make us more efficient, but I've got all the cool shut down now, which I'm very happy about. So, hopefully some of you have seen the McLeamy curve. It's this idea, this was created for design. The idea that in the old process, the majority of design decisions were made during construction documentation. At that point in time, your cost of making a change versus your ability to actually make changes kind of a crossing point, a critical point. It just costs too much then. So what BIM does, not necessarily even VDC, just BIM, is it moves these decisions up forward. Okay? So if you're doing a design build project, you used to have that great billing cycle that we get from architects and engineers, 20, 20, 40, 20, 20%, 20%, 40%, 20%. Be prepared for them to go 20%, 40%, 20%, 20%. Because they're doing more work early. Another thing that I've seen when they go to do this is they've switched to BIM, and all of a sudden they're spending all this money and they're having to bill 40% here. And lots of times some senior executive will come in, look at their cost curve and their spending curve and say, the project's out of control, there's too many changes, it's all a disaster, kill all this BIM stuff, we're going back to 2D. What did they just do? They spent all this money to get to here, and they said, scrap this, we're going to go back down, and now we're going to go here, and they've just doubled their cost on the project. Not because something was going wrong, just because they didn't know what was coming. If you can eliminate that little bit of ignorance, that's going to help you a whole bunch. So what if we take and we drop this back to construction? That was an architect's view. Let's look at a contractor's view. Okay? Same thing. Our ability to actually make a change on the project is going down as we come across. And our ability, and then the cost of making those changes is coming up. How many of the contractors or trades have been accused of overcharging the owner for change orders? Because it cost a lot less to do it here than it did when we had to do the change. We're not gouging them, that's just the way it works because it costs more to make the change later. Okay? This curve has helped me in that conversation too. But what I want to talk about here with this curve in construction, and you can see how we arch this, this even really needs to carry over here, because if you start talking about submittals and shop drawings and everything, I've promoted that they take this arch, and a lot of decisions are even made here halfway through construction. Okay? This boundary of realization, that is something to consider. That moment when all of a sudden no longer is it an idea, no longer is it a concept, it starts becoming physical. Because when we have to physically change things, that costs a lot more money. Okay? That is the point where you want to make sure, as soon as you hand off from documentation to actual construction, you're crossing that boundary. And so that's when the more information we can get, that's good, then it's bad. So let's think about this boundary of realization a little bit. Okay? You have an informal boundary during the design process that if all the questions up here cost you almost nothing. But once you start documenting it and start putting it into models or plans, now it costs the design team more to go back and change it. That is an informal boundary of realization. Because it's not totally real, but it's recorded and it's distributed. Okay? Watch for that. Your formal boundary of realization, once again, is construction. Okay? And I pulled these straight up from the Construction Progress Coalition to show them here today, but I wanted to have that conversation about formal boundary of realization because I want to talk about this idea makes a difference in the profitability of our BIM process. We have a person, the owner, that decides they want to build a building and they have this great idea. The problem is in their brain, the idea looks something like this, right? That's what they have. They know it's great, but that's all they can communicate, okay? So we've got to take that great idea, we've got to start to break it out into pieces. As we start to take that complex, because it is complex, there's lots of decisions, there's lots of options. There's like 40 different ways to build a baseball stadium. Which way are you going to build the baseball stadium, okay? Now we've got to pull in a team of experts. Someone that's a master coordinator that can kind of run the show, and then this team to take each of their own ideas and organize them and find out what is the best solution for each one of those. Okay, then they start to bring them together, make sure they align, make sure they're all supporting the same thing, that the actual square footage and the heating and cooling loads all match up, because you don't want to come in and add 200 tons in the last 4 months. I can tell you how much that costs. And then they start to actually pull them together and coordinate it into a virtual representation. Then that virtual representation and the resulting drawings and shop drawings that come from it are then distributed to the hundreds, thousands, 10,000s people that are actually participating in building this project. Okay, then the project becomes real. So let's look at that and see. There's your boundary of virtual realization, as everybody is putting their individual parts and pieces together. That is one point to make decisions before they cost extra money. The next point is your physical boundary of realization, and that is when the construction actually starts. But knowing where those boundaries are and why they cost money can help us all be much more productive. It's when we focus our time. So as a general contractor or a trade contractor, one of the biggest problems we have in the industry is they don't ask us to participate till here. That's hard bid work. And that's why hard bid work actually costs more than design build or CM at risk or others. GSA just did all their big study on all that and found out that the hard bid work was costing them 15, 20, 30% more. They're still working on the numbers. They just know their hard bid stuff costs them more, even though everybody thinks it costs less. So we're finally figuring that out, and this is why. So with earlier participation is where we can really change that bottom line to the owner and get more value for our participation. So once again, that means in design, getting design right. Right? And so when you start looking at it, you start taking a design and figuring out how we're going to coordinate that early on. Because even when we're in the design process, if we start taking the design information and putting it to a schedule, now we start to communicate it to an owner. How is this coming together? Which areas are being shut down? How is this all working? You can take and put a cost curve to this as well and start to, man, that helps you with the bank. You put a cost curve to this and you show the bank this is what it looks like when I start tapping into my loans, when the cash is depleted and we're coming to you. Things like that go a long ways of being able to pull that together. Being able to, and then coordinate. Authorities having jurisdiction, traffic patterns, right? Okay. The trades, once again, making sure that this is pulled together. This process is what you're after. Okay? Very specific, targeted. If we are trying to get in there with our trades and we have something like a flash cannon tank that has to be replaced, being able to come into, I don't think it played. Oh, it played. All right. Okay? You have project start, mobilization. This is a day. We've actually put our safety icons in there as we're reviewing this with the trades so they know lifting. Don't try to lift this. This is a 2,000-pound tank, right? That guy, there's always somebody, oh, I'm going to help scoot it. You don't do it. Let the crane do the lifting, okay? But talking about those safety icons and then walking them through the sequence. You can see either drain the tank, remove the auxiliary lines are in green. But then walking through, disconnecting the actual main connections, aside from the auxiliary lines. How are we going to rig it? Actually having a decision and conversation and discussing what points do we need. And then actually being able to slip it out. Do we have a plan? It might not be perfect represented there. It might not swing just like that. But at least we have a proof that it will fit. And we've actually used a physical representation to make sure that happens. Now this starts to really change productivity in the field. Because now, yeah, nobody commented, but that thing went boing. I know it bounced. But we can play this over and over again, and we get the trades to go over it. We can go through this a week ahead of time and get a foreman to say, no, there's no way that we'll be able to do that because it turns out that there's another pipeline that wasn't in the model that's not even there. Well, thank you. We put it in the model, we get it fixed. We get it done right. Those are the things that we're after. Okay? So, if we're going to take all this and try to be claims free, because that is a big waste within the industry. The money that, trade contractors, general contractors, architects and engineers put into their project, because we have to be profitable businesses. We have to stay alive, and knowing that these claims are coming, we have to put some money in there to be able to cover them at some point in time. It would be great to be able to slowly eliminate that and pull it out. So, have a good team is one of the first things. Maintain schedule, be proactive, be fair. What all comes down to is no surprises. That's what we got to be open and communicating, working together on it. So, having a good team, this is the team. It's everybody, right? So yes, having a good owner is a part of this. There's projects that I've seen us elect not to participate in because we knew it wasn't going anywhere good. We transfer those projects to our competition. The team here, the design, coordination team, your modeling team, that's design and your trade contracting team. And then the actual team that's out there putting in. That makes a big difference. So, and then the team, the earlier participants are more important than the later participants because you set the trend and you figure out a lot of the issues earlier. Okay, so who is your team? This is the place where really, we don't get to often select our owner, and it's always painful to walk away from a bad owner even though you know it's a good decision. It's still painful. Okay, but this is the team where we really need to focus in on who we're picking, who can actually perform VDC and do it right and get us the productivity and efficiency in the field that we're after. Okay? The idea, working together makes a huge difference. Who is going to set the tone on your project? Every project has a soundtrack. Think about it that way. And what's that sound like? How is it going on the project? Okay? That early coordination of the team, I said aligning those points, making sure that we know where things are really going to sit in relation to each other. If you're doing BIM and VDC, an early point that you need to do is some sort of a naming convention. So like that's the name of a file. But right here I can tell you this is the Volvo project, building 140. It's level 2, area A2. It is the structural fabrication model, and it is created by Schuff Steel on that date. I don't have to open the file to figure any of that out. Okay? Now, naming conventions are absolutely necessary, mandatory for a good VDC process, but wouldn't this help you on daily reports too? I mean, wouldn't this help you on any files that you name on your project to be able to put the project name, okay, the location it came from, the contractor who provided it, the date it's from, all those sort of things. And as a little side, little fun thing out there, that is one of the hardest things I get people to try to do. Year, month, day. But it's so simple. And they all learn as soon as they're on a multi-year project, and all of a sudden all their January files are lumped together and all their February files are lumped together. But now the teachers at school with my kids always look at me funny when I write 2018 February 14 on stuff, but I just make it a habit. Okay. Making sure that we manage our schedules of information, right? The information that's coming. If you get into BIM, at some point in time, they're going to want these links inside the model where I can click on a dry type transformer and that link takes me directly to the website and I see the O&M information. But this has to be done early. If you wait till the end of the project to do this, it's going to be costly and painful. Okay? That's why I have it under the schedule side. Timing is critical on things like that. Okay? Getting it done early enough and actually coordinating the quarry tile. Here's quarry tile coming out to go back in 2 inches higher so that it has the slope so all the water runs out of the freezer when they defrost it. Simple things like that. Coordinating this one, clash detection, simple clash detection. But you start to say, well, why don't architects and engineers do it? Well, in this particular instance, that footing is clashing with a landscaping drain. Not many people are coordinating their structural engineer with their landscaper, okay? But those more into the model helps your schedule, because otherwise what we have done, we'd have been out there in landscaping the last minute. We're really trying to get everything put together and the building turned over for Black Friday, because if you don't turn the outlet mall over for Black Friday, no one's getting paid, right? That's what it comes down to, okay? Being able to how quickly can you turn around an estimate? How quickly can you find out what changed from one revision to the next? Right? Using tools like that to be able to highlight and see what did they change. Or being able to drop into a model and say, there are 4 of these. Where are they? They're on the schedule. One of the best ones was a project we had 2 light fixtures, 290,000 square feet, and on the lighting schedule there was these 2 specific light fixtures and no one could find them. Well, it turns out the electrical engineer, they were on the schedule, but they hadn't been marked on the plans. They were in the model, though, and we found them, and that was very helpful. Here's another one, quick video. We talked about communication, collaboration. This video early on, I'm going to skip ahead a little bit, okay? If you'll notice that, this is baseline to actual comparison. You'll see what's the best thing about this video? The project's ahead of schedule. The stuff in the actual is happening before the baseline, okay? But communicating that early and making it highly visual so that the owner understands we are ahead of schedule. So then that way later on when you see that all of a sudden the rest of the building, the baseline, overtakes the actual, and it really starts to happen when we get to curtain wall, on some of the major curtain wall around the back, then later on you have that conversation, and the conversation is so much easier to have because the nuances are gone and it's visual, and you can really be talking about your schedule and how it compares. Okay? Being proactive. So on this particular project, we went into an area of the country that hadn't done any BIM before, hadn't done any VDC, and we knew we needed to do it because we had to help the owner, and so we started classes talking through it, and so we did a mock-up. So we were due a mock-up. We had to provide a mock-up. Well, the concrete guy, the curtain wall guy, the metal panel guy, the louvers, all of these different groups, they started, well, what am I providing for the mock-up? Well, first thing, we're going to model the mock-up. And we're going to use the actual dimensions from it walked us through the whole process with a whole group of trades that had never done it before on a nice little small thing that was easy to get their head around and easy to change. Coordinated origin points. We did the whole process all the way through. And yes, there was some humming and hawing and grumbling, and I even got cussed out once because this is a whole waste of time until they saw it and they got it. And then when we actually went and built this mock-up and we actually resolved project issues using it, then it was very beneficial for everybody. But that was a very proactive way to approach it. So the biggest thing about being proactive is don't wait for BIM or VDC to be a requirement on one of your projects. That's like showing up for the test without studying. Start figuring it out before it's due, before it's required. Okay? Getting out there, showing the owner what the model looks like ahead of time. Laser scanning not as an as-built. Laser scanning as a proactive. How are things going to fit is a very significant, important thing to do. Virtual mock-ups can be very significant. This is a virtual mock-up. But this is an actual virtual mock-up where they went and got fabric samples and they went and were shown pieces of artwork and took pictures of them. They were actually spec'd Kohler fixtures and said this is what they should be. I'll put in all of that in there. Okay, here's another one. Being fair. This was a model I put together on a particular project. When the project was bid, the black represents what we were told the static water line was. Okay? This represents, oops, the static water line was actually 12 feet higher. You think that makes a significant difference when you're digging footings, when all of them are underwater versus all of them are a foot above the water line? Yes. And so that was something that we worked on there. Now, taking this to the owner was very significant and very important. Okay, it just made it that much easier to have that conversation. And all of a sudden, oh, it does make a difference. Because the owner wasn't trying to be a jerk or anything. They just didn't think it made a difference until we showed them a picture. And that was in progress in the project. And so that's another thing. We didn't have to wait till the end to fight this out with an arbitrator. We were able to deal with it as we went very nicely. So that whole idea of the sooner you can deal with something. If you can take care of it before it gets real, before you cross that boundary of realization, the cost and the effort of changing it is greatly reduced and all of your conversations are easier. The best way to do that is with BIM and VDC, because you can actually see how it's coming together and you can find the issues faster. So when it's all said and done, cool is a terrible business plan. So go out there and do this for productivity. Do this for reducing the cost overall and making sure that people are getting what they actually need. Okay? And that's one thing to think of. If any party this is saying that BIM or VDC costs more, it's because they haven't figured it out yet. So that's one of your flags right there. Okay? So, as a summary, we know that ignorance and chaos exist. There's a pretty good way to take care of it. Okay? There's my little pitch. And this is one of my funnest things that I saw this movie, and I just play this in so many seminars because I see this all the time with superintendents out on the job site, and I see it with company owners, and I see it with others. I'm going to push play on this, and then we'll pull it back together.
You need men in these buildings. There are people inside, and they're going to be running right into the line of fire. You take them through the basement or through the subway. You keep them off the streets. I need a perimeter as far back as 39. Why the hell should I take orders from you?
I need men in those buildings, leaving people down and away from the streets. I'm going to set up a perimeter all the way down to 39th Street.
Okay? I've been there, done that. Why should I listen to you? Show them, right? When you get those skeptics, when you get those people that say this doesn't work. You get an architect, oh, this doesn't work. Let's show them. Let's show them that it works, and then they'll be our biggest allies, and they'll be out there. And we might not be saving lives, but we can't all be superheroes. Thank you.